First off, to understand VLANs, it's important to clarify how they differ from subnets. Some may confuse the two or believe they have to be tied together. However, while they share certain characteristics and goals, they differ in their operations and requirements. Both VLANs and subnets achieve segmentation within different layers of the OSI model, which means they both allow for traffic engineering and network security opportunities. VLANs, however, work on layer 2 with Ethernet frames, and subnets work on layer 3 with IP packets. One of the most important things to understand when talking about VLANs is tagging. VLAN tagging works with the use of a 4-byte VLAN header inserted into every Ethernet frame containing 4 different fields. TPID, a 16-bit tag protocol identifier, PCP, a 3-bit priority code point, DEI, a 1-bit drop legibility indicator, VID, a 12-bit VLAN identifier, also known as the VLAN tag. I will leave the PCP and DEI fields for other videos as they relate to quality of service integration for VLANs rather than the direct VLAN tagging functionality. The TPID tag protocol identifier field is however important as it will define the protocol type of the VLAN tag, which in most cases is 0x8100, meaning the IEEE 802.1q tagging protocol. Then we come to the second largest field, the VID, meaning VLAN identifier. This field allows up to 4,095 unique VLANs, but only with 4,094 usable VLANs due to the fact that VLAN 0 and VLAN 4095 are not usable. VLAN 0 is allocated for frames that arrive with no tag but have quality of service parameters attached, signifying a level of priority. This makes sure that these frames can also be passed without being dropped. 4095 is primarily related with virtual machines and in summary allows for virtual guest tagging, which means that VMs can tag their traffic on their own. There are 3 port types in VLANs: access, trunk, and hybrid. Access ports, also known as untagged ports, will not tag any traffic as they will only service one VLAN. So if you have a computer and you want it in VLAN 10, you can attach it to an access port with VLAN 10 assigned to it, and it will automatically be VLAN 10 traffic. Trunk ports, also known as tagged ports, will tag all traffic as they need to be able to recognize many different VLANs. This is because a trunk port will be used on connections that require more than a single VLAN. For example, if you have 2 different switches and you want to have 3 VLANs, say 10, 20, and 30, spanning across both switches, you would need to use a trunk port on each switch to form a trunk link, allowing for all the traffic of the 3 VLANs to traverse the link. Trunk ports, however, need more attention as you want to make sure they only allow the VLANs required to make sure your network stays secure. Hybrid ports, as per their name, are a hybrid between access and trunk ports that allow both untagged and tagged traffic. An example use case of a hybrid port could be connecting a phone that has a PC daisy chained to the phone. The phone may know how to tag its traffic, but the PC will most likely not, meaning that unless you either have a hybrid port or a trunk port with a native VLAN configured, the PC will have no connectivity. Most suggest the use of a hybrid port in this situation. Different VLAN types. The management VLAN allows administrators to have uninterrupted, smooth access to system control within the network device. The management VLAN will have a high priority, meaning that even if the network is congested, the administrator will be able to access what is needed without issue. The data VLAN is designed for user traffic and effectively segments user traffic from VoIP and management traffic. The voice VLAN is designed for VoIP traffic and will have high priority within the network to make sure VoIP traffic achieves low latency. The default VLAN, normally VLAN 1, is the VLAN that a switch puts all of its ports in upon boot up. All control plane traffic is also within VLAN 1. The native VLAN is for when trunk ports receive untagged traffic, instead of just denying it, they filter it into their native VLAN, normally being VLAN 1. VLAN design is a very important factor when designing an efficient and secure network. VLANs on their own are able to segment traffic. However, when you introduce inter-VLAN routing, things become more complex. When you have routing between VLANs, like most networks today, you need to ensure you have appropriate ACLs, access control lists, in place on the router to prevent unwanted communication between VLANs. If you do not create these routing ACLs, then your devices can freely communicate with other devices in other VLANs, which defeats the entire purpose of VLANs. Another question you might pose could be, how do I lock down the communications within a VLAN? And your answer would be either with VLAN ACLs or private VLANs.